So now let us see an example. Here is the algorithm which finds sum of n numbers in an array. Okay, so in this algorithm we have an array A, total number n, and we are finding sum of all the numbers in an array. Okay, so that is the code or algorithm for the problem in which we are going to sum all the elements of an array. So now what we will do, while calculating frequency count, we will make a table for statements and we will see how many times each statement will be executed. So we will break all the statements like this. First, we will write this statement, then we will again break this for loop. So we have 3 statements in for loop. So we will write all 3 statements over here. Okay, then we will write this whole expression as a statement over here and then this statement. Okay, so first of all, we will break down all the statements of an algorithm. We will make a table in which we will record all the statements and then we will find the total cost associated with each statement, that how many times each statement is executed. Okay, so let us see first statement. So we are initializing some variable. For the s variable is used for finding sum of the elements. Initialization will run one time. It will be executed only one time. While initializing variable, we will take 1 unit of time. Okay, again same thing, I equals to 0 will run for 1 unit of time, means it will be executed one time only. Okay, how many times this particular statement will be executed? So we need to focus on this statement, as in this we have to analyze carefully that how many times this statement will be executed. Okay, so let us now see I less than n. Okay, so we are going to compare this. So how many times this statement is going to be executed? Let's say if we have total 5 numbers, so our n is 5. Okay, and suppose we have I which is starting with 0, right? So first of all, we will check the condition. If I is less than n, condition is true. Okay, again we will increment I by 1. Now we will check the condition. It's true. Increment I by 1. Compare I and n. Condition true. Okay, again condition is true. Again condition is true. Now I will be incremented by 1. Okay, and will become 5. Now we will check if 5 is less than 5 or not. No, 5 is not less than 5. So how many times this comparison happens? 1, 2, 3, 4, 5 and 6 times, right? So n is 5. This loop is going from 0 to n, and this total comparison which this statement is checking, condition checking, will be done how many times? 6 times. So if we want to write this thing in general, then what we will write? That this statement I less than n will be executed how many times? N plus 1 times. This 1 is for false condition, when your condition will become false. So this additional 1 is added for the false condition. When your condition is false, then you will be out of this loop. Okay, so this statement will run one time, this will run one time, this one will run n plus 1 times, as we have seen, right? Now, how many times I plus plus will be executed? For example, if this is running n plus 1 time, and if this one is for false condition, then when your condition will become false, upcoming statement means next statement will not be executed after your condition becomes false. Okay, so I plus plus will run n time, but not n plus 1 time, because when this condition is false, this statement will not be executed. Also, this statement will not be executed after the condition becomes false. That's why your I plus plus statement will run only n times, and this statement inside for loop will also run how many times? N times. Okay, so I hope this thing is clear, that I plus plus and the statement inside for loop, both of them will run n times, as after condition becomes false, compiler is not going to execute these two lines after condition becomes false. Okay, so this one additional one will not be added in this statement and this statement, right? Then let us see, we are returning a variable. So returning a variable will be executed only one time. So this will take 1 unit of time. Okay, so now this will be the table which you will maintain to record frequency count, and all of these are nothing but what? Called as cost. Means the frequency count of each statement, how many times each statement is executed. So now let's sum up all of these. So we have how many n terms? 1, 2 and 3. So we have 3n and we have 4, 1. So total frequency count which we will get is 3n plus 4. And this indicates running time complexity as a function of input size n. So as n increases, complexity increases, right? So for example, let's say if n is 1, then 3 plus 4 will be 7. Then it will take 7 unit of time if your input is 1. If your input is 2, then 3 into 2 plus 4 will be what? 10. Okay. If your input is 3, then it will take 13 unit of time, and so on. Means if your n is large, then it will take more time, right? So this indicates the running time complexity of the given algorithm. Let us see another example for performance analysis and measurement for frequency count. Okay, this is the example of multiplying two matrices. Okay, so we are going to multiply two n cross n matrix, and the resultant matrix will also be n cross n matrix. Okay, so this is an algorithm to multiply two n cross n matrices, and we will store the result in n cross n matrix. Okay, so in order to multiply two n cross n matrices, we will have two matrices as input and the dimension n as input. So we have three inputs in that case: matrix A, matrix B, and dimension of the matrix, right? So suppose we have two matrices, one dimension is m cross k and another matrix's dimension is k cross n, then the resultant matrix will be having m cross n dimension. Okay, as for example, say for example, we have two matrices, one is 2 cross 3 and second one is 3 cross 4. So for example, if we have 2 by 2 matrix, and again another matrix is 2 by 3. Okay, so size of this matrix is 2 by 2 and size of this matrix is 2 by 3. Okay, so suppose let's indicate this dimension as m cross k and this dimension as k cross n. Then the result of the multiplication will be what? M cross n, that is 2 by 3. So resultant matrix we will get will be 2 by 3. Okay, so this thing we need to understand, as the condition for multiplying two matrices is number of columns in first matrix must be equals to number of rows in second matrix. Okay, so number of columns in first matrix must be equals to number of rows in second matrix. If this condition is true, then only we can multiply two matrices having different dimensions, right? So if we have M cross K matrix, that is your first matrix, then this number is nothing but number of rows. So both of these dimensions are going to be same. Okay, so if we have two matrices M cross K, then in second matrix this size will be the same, as this represent column of first matrix, this represent row of second matrix, right? So in that case, the resulting matrix will have size M cross N, as we have done here. If we have two matrices A and B, then index will range from I, K and K, J, right? So resulting matrix will be having size I cross J. Okay, so this is how we can multiply two matrices. Now let's see how do we calculate frequency count of matrix multiplication algorithm. Okay, so first we will break all the statements, right? So we have three statements in I loop, three in J and three statements in K. So first we will write all the statements of an algorithm like this, and then we will associate cost in another table called frequency count table, right? Let's break them and write it into statement table. So we have these many statements. So we will associate cost with them one by one. So initially I0 will take 1, as we have already seen. Initialization will take 1 unit of time. Okay, comparison check will take n plus 1 time, 1 for false condition checking. When condition becomes false, we will be out of the loop, right? Then this increment operator will be executed n times, as after condition becomes false, it won't be executed. So this plus 1 will not be included in this or other statements which comes after I plus plus, right? So if I plus plus is running n times, then the statement which comes after I plus plus will also run n times, right? So for example, here we have loop J, that is a nested loop, right? So as this is nested loop, it depends on loop I. Okay, and how many times I is going to be executed? It is going to be executed n times, right? As after this condition becomes false, the statements after I plus plus will be executed how many times? Only n times. That's why as J is dependent on I and I will run n times, we have to write this n for loop I. Okay, and then we will multiply the cost of J loop with this. Okay, so its own cost of initialization is 1. Okay, the condition checking of J will again take how much time? N plus 1 as this. J plus plus will take how much time? N times as I plus plus, right? So we will multiply these two and final will be what? N. This will be n square plus n, and this will be n square. Okay, these are nothing but 1, n plus 1, n. Right? Now this statement is initialization and it will take 1 unit of time, but again this statement is dependent on these two loops, right? So we have to associate cost of I loop, cost of J loop and its own cost, that is 1. So this will run n square times. Okay, same for this statements also. K is dependent on I and J both, and both of them will take how much time? N unit of time, right? So we will write n into n for I and J, then we will associate its own cost. So its own cost of initialization is what? 1. Condition checking will be n plus 1 and increment will be of n times. Okay, so it would be n square, n cube plus n square. This will be n cube, right? Now the last one is assignment statement, and again, how much time it will execute it? It will be executed exactly same as k plus plus, as it will be executed after k plus plus, right? So it will be dependent on I loop, so we'll take n. It is dependent on j, it is dependent on k. So n into n for I, j and k, and its own cost is what? 1. So again it will be what? N cube. So the total we get is 1n cube, 2n cube, 3n cube. So total we have 3n cube terms. Then let's calculate n square terms. That is 1, 2, 3, 4, 5. So we have find 5 n square terms. How many n terms are there? 1, 2, 3, 4. So we have 4 n terms. And how many constants are there? So we have n plus 1. So 1 is here and 1 is here. So 1 plus 1 is 2. So this is the total answer of this frequency count. So let us compare the answer, and we will get 3n cube plus 5n square plus 4n plus 2. Okay, so this is how we can find frequency count of any algorithm.